So hello everyone once more. I guess we have everybody who wish to join now and we're able to start our webinar. The topic of our webinar is OpenCloud as a tool, as an opportunity. A brief introduction of the persons who will participate today in our webinar. Ilya Zavyalov is OpenCloud team lead. Dmitry Borisov is OpenCloud software engineer, and me, Alexander Borovikov, is the customer experience team lead. The plan of our webinar is the following. First of all, we'll provide a brief overview of what OpenCloud SDK is. Then we will provide information about what OpenCloud can do for you, the main block. We'll provide information regarding what's next, the plans of the near future, and the session dedicated to questions and answers. We suggest you to ask your questions in the text box, in the chat box available, so we could proceed them efficiently, merge the similar questions and answer them, so to provide as much information as possible during this question and answer session. And overview. What were actually the goals of the OpenCloud product and why we started this SDK? Open Design Alliance is well known for its CAD and BIM solutions, and the purpose of this product was to provide an agile cloud platform to leverage all the ODA benefits in the cloud, I mean CAD and BIM benefits. And what's more important, to provide our members with the opportunity to build custom solutions on top of this platform and to provide them a choice where to deploy these solutions on public cloud or private server. Some of the members are probably familiar with the Web SDK, the product that was earlier introduced to work in this direction as well. This slide illustrates the key differences between those products. First of all, it's necessary to say that OpenCloud is based on the technologies that were first introduced in Web SDK product, but with the purpose to form a holistic product, because Web SDK was more a set of tools, and OpenCloud is a self-hosted server. Thus, it is easier to start working with it, and it's more convenient to work with it. So it on one hand is a mature product because it used the technologies that were introduced and approved earlier. On the other hand, it incorporates the feedback and the information that was provided by members who used Web SDK and faced various issues with that. And now a block, an overview of capabilities that can be provided by the OpenCloud SDK to you. First of all, like any cloud product, it helps to connect teams and projects, what's called the cloud collaboration. The next item is improving your documentation management systems. So we introduced the preview capabilities that may be used in documentation systems and thus enhance their capabilities. For instance, it's possible to visualize some model, because nowadays CAD and BIM models in architecture, in design, in consulting companies are a significant part of the overall documentation stream, and being able to exchange them efficiently and being able to manage them efficiently in this documentation stream can be a significant advantage. And what we have is not just viewing with the basic capabilities like zoom, rotate, and similar things, but it's possible also to, for instance, hide some entities, thus to emphasize the attention on what's inside on something particular. Moving forward, What else can be provided? It's also possible not to visualize, but to get the exact particular data from CAD and BIM models. And what's more important, we can get it using the handles. So we do not obtain all the properties of the model, but we can send the handle to the server and get the particular property that we need. So the traffic will be very low and there will no be heavy load to the channels and similar things. Thus, it is possible to do it quite quickly. Another option is more administrative one, is saving your money, because OpenCloud is the part of standard membership. So if, for instance, you switch to our pricing page, you see that's even selecting non-commercial membership, you get OpenCloud as part of that. So it is available for development for all our members automatically. And if you are ready, if you if you design some worthy solution that is possible to distribute commercially, what you need is just upgrade to sustaining membership, thus being able to distribute open cloud-based solution. So no problems about it. I mean that it's not a service, it's an SDK under your full total control with straightforward pricing. And we'll review those capabilities from probably a more technical point of view. So what we have visualize features, as I said, and a couple of words of how it is organized. We have the model on server, and we have a special library in a WebAssembly format in the client side. And as soon as we obtain geometry from the server, we're able to visualize it on the client side. So as it was shown, it's possible to see the model, but what's more important, we can have not only the geometry from the model, but we can have auxiliary geometry as well stored on the server, obtained and visualized with this auxiliary library. And an example of this auxiliary geometry is the markups. So it's possible to emphasize some aspects, some elements. It is possible to store the markups, and it's possible also to load the markups that were saved before. So thus sharing the information, working together on some particular model turns easy and more efficient because all the data is stored on the server. What else? It's possible to view the drawing object properties, to perform the export on the server side, for instance, to PDF, and thus share just a link to the resulting PDF file. So sharing turns quite easy. It's possible to have the basics of the management. So you store and manage your CAD and BIM drawings. You can control the auxiliary data that was created, PDF export files and similar things, and manage, add or remove them, and store and update your users' information. So you can form some categories and grant privileges, control the access to the models that are stored on the server. And a more technical view on this point, a couple of words of how we do it. So this is the picture illustrating the structure of the OpenCloud. The key thing is the OpenCloud server that operates with the MongoDB database, with the file system, and the job runner that runs the jobs and to perform the tasks required. And as you see on the web application, we have those WebAssembly library called VisualizeJS that is in charge of visualizing the geometry. And a couple of words of how we get it. So VisualizeJS also is not something written entirely from the scratch. What we do, we use our Visualize SDK, the C++ SDK, and with the tool called Emscripten, we compile it in the WebAssembly format. Thus, we increase the reusability of the existing code, and we can rely on it because it's something that is already tested and used. And what's more important, this approach provides us additional benefits. For instance, if some useful feature is implemented on the Visualize SDK side, we are able to get it quite quickly on the VisualizeJS side, similar to, for instance, markup editing or other things, or visual styles. So we are able to get it quickly and to have it on in browser visualization or another manage. This short video provides a brief illustration of how you can build a client. If necessary, we can show it. We increased the speed of some extracts, but and now it takes about 3 minutes. I mean the length of the video, but the actual length of all the steps is about 7 minutes. First of all, we need to install the prerequisites. The prerequisites required are enumerated in the documentation, so there are no questions, and this procedure is automated, so that shouldn't be difficult. As I said, we try to proceed the experience obtained with the SDK. Now what we need to adjust some settings and specify the address of our cloud example link with the headings. Now, after we have this done, we need to build the client. In real life, it takes about 2.5 minutes. At least on the desktop we used to record this video, and then we start the client. It addresses our demo server, and as you see, though the link points to the localhost, we are able to log in and act as we are on our demo viewer. So that's it. And as another block dedicated to Microsoft Azure, as we wish to provide support to our members on all steps, not development only, but deployment as well. We consider one of the possible variants of deployment as Microsoft Azure, and Microsoft guys are open for discussions. They participated in our development conference last year, and thus we introduce some adjustments and some help how our solution may be deployed on Microsoft Azure. What we actually do for the key parts of our OpenCloud structure, we introduce the possibility to use the Azure services. So the job runner runs on the virtual machine. Azure SMB is used as the file system. Azure Cosmos DB is used as the database, and Azure Front Doors is used for on the client side as the point entering point for the client side. Briefly, that's it, and it's also an approved solution. You can find our page on Azure Marketplace for everyone who is interested, and thus it's possible to leverage all the benefits of OpenCloud through Azure, or all the benefits of Azure through OpenCloud, whatever you like. What else I would also like to add before we switch to more administrative issue, that the cloud example that we have was designed for working on the desktop. But the approach is quite universal, so it is possible to try our cloud example on a web application, on a mobile device, and right now I will try it on my smartphone. Okay, looks now it is correct. And you can see the cloud viewer opened. We'll try some file. Please pay attention that screencasting occupies some resources, thus the actual situation is a little bit better without the screencasting. So we have a file. As I said, the application, this cloud viewer wasn't designed for mobile application, thus the touch screen capabilities are not available. But we can use the existing clickable options that do not require the touch screen capabilities. As you see, we can switch between the predefined views. We can change the visual style, and in the same manner, we can load one of the predefined, pre-saved markups. So you see we have it. We plan, of course, to modify the example and to make it available and convenient for the mobile usage as well. But currently, you see the situation is such. The next block, when working with the OpenCloud and obtaining the feedback, we revealed that it is a very significant, very big area where different members have different priorities and different directions are available. So we made it possible, similar to other ODA products, to create special interest groups and to invest in the particular directions, in the particular features to make it possible to create some unique competitive advantage on top of our OpenCloud platform. So if you are on the OpenCloud page, you can just scroll and request the necessary information, ask your questions, and we'll be glad to discuss it. What's next? A brief overview of the features that are planned for the near future. First of all, this measurement API, because this feature was mentioned and was requested by the existing users of OpenCloud, by our existing members. So we expect this feature to appear probably in a couple of months. GLTF support that should enable and extend our capabilities with the third-party integrations and for 3D models. So with 3D geometry, this feature is already implemented. Partial BCF support and some new features for the OpenCloud server, such as asset support of folders, projects, and so-called endpoints, and Azure Blob Storage support. This feature is also requested by our existing members, and as far as I know, Azure Blob Storage is probably the cheapest storage service provided by Azure. So, of course, it is reasonable to use this type of storage for deployment. Before we start our questions and comments session, I would also mention the following. We plan to have our development conference in September. If the overall situation in the world will be okay, we will have this in Munich in BMW World Center in September 8 and 9. If the situation doesn't change to better, I think we will have this conference online in the same dates. So at least please pay attention to it and consider the dates. And we also engage you to join our next webinar that will take part in April about the BIM RV SDK. The webinar, the SDK that provides Autodesk Revit file support. So it will be on April 22, and we will be glad to see you all. The registration is already possible. So we'll be glad if you join us on April 22 as well. That's all with the presentation part, and now I give a word to our OpenCloud team lead to provide answers to your questions.
So what does a handle look like? Actually, the handle is identification of the object from the native database. It means that through these handles you can connect the visualization, the object which you can see in the browser, and the native object in the original file, in the source file. And actually it's represented as a string, because from the OpenCloud server you obtain the in JSON format, all the data in JSON format. The next question is what is the relationship to job runner and controller and workers? Honestly, in the current version of OpenCloud, there is no controller and worker application on the backend. We provide only job runner with console application. We name it file converter. And the main idea that job runner is a light application which run file converter application to convert files to another file format, or to extract geometry data or properties data. The controller and the workers, we leave them because some of our customers already use it. So we decide to leave them for supporting. So we got tests, we got some basic documentation about it using, but currently we don't develop it. It's quite stable, but we don't move forward to support some new features in these tools. Okay, next question. Markups are nice, thank you. But does OpenCloud support the BIM collaboration format? Yes, I agree that we need to support the BCF on our backend side, and actually we got in our nearest plan to support this feature. It will be not replacing for our markups, but additional functionality, additional API. I think that maybe in next release 21.4 we will provide this functionality. Okay, next question was what the hardware are required on the server side. Good question. So there are actually two main parts of our OpenCloud solution, and they got different requirements. For example, we got OpenCloud server, which is written on .NET Core, and actually it doesn't have some heavy parts, some heavy functionality. And right now we are preparing performance tests for it to understand how much requests it's possible to pass to process on our Azure virtual instances, and results we will publish in our documentation and through our other channels. But in the second part of our solution, it's a job runner. It's actually these parts perform the really heavy work because it needs to open the source files like Revit files, like DWG files, and it will be depending on the file size, on the internal structure of the size. So I got the right now we are use virtual instances on Azure with 16 gigabytes of RAM memory, and I don't remember right now about the CPU unit, but we will provide this information in near future in our documentation. So the main idea that you need to provide the really good hardware for the job runner. But for OpenCloud server, you can use some middle size of your virtual instances. Okay, the next question. What's the program language? We use .NET Core 2.2 for our OpenCloud server. We use C++ code for our job runner and file converter tools. And on the front end, we use JavaScript, but it's used for our demo application, demo viewer application, and it's like only a demo. So we provide the sample. It's quite huge sample, I understand it, but it's only a sample to understand how to implement some features from our solution, and it can be the base application which can be used to implement your use cases. Okay, the next question, will it store any files in local browser? It's not clear. On the browser, we are storing only the geometry data. So all files like Revit, DWG, DGN, and others, we convert them, we extract the geometry data, and we use for geometry data, it's VSF, our visualize string format from Visualize project. And these data stream it directly through the OpenCloud server on the browser, to the browser. So only these data are stored in the browser. The next question is, will the VisualizeJS version make the Android or Objective-C version obsolete? I actually can't say right now directly answer on this question, because the VisualizeJS is a part of web application, and the web application on mobile devices, maybe it's not perfect fit for some user requirements. So I don't know actually, is it maybe for some cases, for some stories, it will be a perfect solution to replace the whole stack for Android platform, for iOS platform. But for other cases, maybe it will be not so perfect solution, perfect replacement. So I can say directly on this question. Okay, the next question. We are excited about the measurement feature. Could you please tell us more details about measurement API? Will it be point-to-point measure, line measure, and so on? Right now, we check the similar functionality from other products, and I think it will be similar like in Autodesk Forge solution in the web viewer. So the basic requirement is to provide the tool in VisualizeJS API to measure distance between different points in the SAM. These points you can select them directly with our snapping functionality to perfect fit your mouse position between different objects, and it will be the distance measurement and the angle between 2 points. So I think it will be the basic functionality which we will provide, and then we will wait your questions, and maybe we can find something interesting cases, and we'll provide the solution for such cases. Okay, the next question. Do you consider OpenCloud solution a prototype or ready for a company to rebrand, customize as a commercial product? I think that yes, right now it's a ready solution which you can already start using as a replacement for some other solution which you already use. So the basic functionality right now is storing cut and beam files, extract and convert those files to different formats, and extract geometry and properties data, and visualize them in the browser. And of course, the markups, the nearest plan is to support measurement tool. It's all ready-to-use solution, ready-to-use functionality, which can be used in the production mode right now. Okay, the next question: are there any performance issues with large models? Actually, in the Web SDK version, we was able to stream geometry and display not the full scene, but only part of them when this geometry cannot be fitted into the client memory, to the client device. Right now, in current solution, we don't have such functionality right now, but we got a nearest plan to support this functionality too. So it will calculate the amount of used memory on the client device, and will load the scene, maybe the whole scene, maybe the part of the scene, which can be fitted to this limitation. But actually, we don't have any other issues with performance large drawings. We got functionality to speed up of the rendering. We just, during user interaction, we just discard some small objects from the scene, so the users can quite smooth and easy perform its interaction, like pan, zoom, rotate, and so on. And when the user interaction is stopped, the VisualizeJS start drawing the all other parts of the scene. It's actually how it works right now. Okay, the next question. If I import an IFC file into OpenCloud, will I see on the client object browser the semantic IFC data? I think yes, but maybe not the whole data. Need to check it, because some solutions, as I know, open IFC files directly from the server and render it on the browser. It's like IFC files. But our solution a little bit different, because we provide solution for rendering a lot of different file formats. So to support such workflow, we need to convert all source files and IFC files to our internal representation, to our geometry representation. So during this conversion, all semantic of IFC formats is losing a little bit. You don't have information about specifications of IFC objects, maybe some other information, but you can obtain it through the properties mechanism, you are able to, with our OpenCloud, to load the properties for each object or for a set of the objects, and through these properties you actually able to obtain this information which you are needed for IFC. But maybe this information is not full, so I don't know, you need to check it. Maybe it will be enough for your cases. Okay, the next question will be a blazor implementation in the future. It's not clear what you mean the blazor. Is it maybe it means that okay, on the client side we provide VisualizeJS, and that's it. So you can use any technology which is compatible with WebAssembly, with our VisualizeJS library. So it's a huge variety of different solutions. Like on JS, it's Angular, actually Angular on TypeScript, but React, the plain JavaScript, some other, it's like C#, and some other technology which can be used for writing web application. Okay, the next question: does the VisualizeJS in client side renders each model data in client using webGL? Yes, we use YAML scripting, and we cross-compile our rendering part, which are using OpenGL. And during this compilation, these draw calls compile it into WebGL, draw calls. So yes, VisualizeJS is using WebGL. Or is it a render in the server and only pixels are shown through the client VisualizeJS? No, it's only a WebGL solution. We don't provide screen streaming from the backend. How large can a model be loaded in client side in either of the cases? It's hard to say, because we understand, we realize that there is no strong the geometry data is not depending on the original file size. So I can say that TWG files, which takes approximately, I don't know, 400 megabytes, will be easy to rendering in our solution. Because maybe yes, but maybe not, because it may contain a lot of different objects and the sand will be very heavy. So maybe in these cases we got a limitation in our RAM memory. But we actually perform different optimizations with our visualize stream format. So right now we are, as I said previously, we are working on the update manager functionality, which actually will load not the full sand if the sand will be really huge and heavy. In these cases, we the VisualizeJS will load only part of the scene, some significant part. So in this workflow, it will be easy to provide access to any drawing, because such workflow provide the basic mechanism for working with drawings of any size.
Looks we missed one question for a small sustaining member, like someone.
Okay.
What would you say would be the value for them and for their clients for a small sustaining member? Briefly speaking, the value is that it is possible to make something like an addition, for instance, to Forge and to distinguish their needs. So you do something with Forge, and we know that there was interest in this direction, but some simple application, some simple requests are processed locally on a local server with local storage and with local web visualization and the possibility, a local possibility to obtain some data and properties of the data. So that may be, for instance, one of the use cases to decrease the number of requests and thus money spent for using Forge, for instance, like the first idea that occurs.
Thank you, Alex. I missed this question. Okay, the next question. Can we write our own converters? It's not clear. Converters from your file format to our visualize string format, or from visualize string format to your format for rendering in some other third-party rendering. But actually, yeah, you're right. It's possible in both options, in both ways. You can implement converter to visualize string format, and as I know, we already got such cases, and it's actually possible to convert the visualize string format to different other formats for rendering in the browser, for example. In the same way, we are now providing the conversion to GLTF format. So it's possible to open these drawings in 3JS, for example, in 3JS rendering engine. Okay, the next question. Are there any plans to support drawing editing using OpenCloud? Actually, right now, we don't have such plans. But Alex, you already mentioned that we got some workflow for users who want to support some additional functionality. So you can write your requirements, and maybe it's possible to create some additional SIG group for this to support, to implement this functionality which you are needed right now. And yes, you need to modify the drawing. You need to use worker and your custom commands. That's true. So actually, for such cases, we support our controller with workers. Okay, the next question. We don't use your visualize components, only the web file converter. Read DWG and convert to JSON, and then write back out to DWG within our own microserver. Okay, perfect. Can you confirm that the latest version of the ODA Web components support .NET Core framework? As I understand, you mean that you asking about .NET Swig wrappers. Not actually. We don't provide the access to the drawing through the .NET Swig wrappers right now, but you can use it additional. It's like your I think that our OpenCloud solution is not fitted to your requirements. We don't provide access to DWG format for modification. Okay, the next question is GPU required on the server side? Actually not. You don't need the GPU on the backend. It's possible all operations for conversion source files like DWG, Revit, and so on to our VSF. These operations works without GPU units. Okay, the next question: how can I extend the OpenCloud server? For example, can I call other REST services when I upload a file? Yes, you can even implement communication between your backend, your server, and our OpenCloud server. For example, if you want to do some operations with DWG files, so you can download it on your backend, perform some operations, and upload the new version on the OpenCloud server. But yes, in these cases, you need to extract geometry again for this new version of your file. Okay, the next question. Can you provide an idea of the performance compared to other services? Okay, if compare our solution with Autodesk Forge, for example, from on the client side, on the front end, we got the maybe similar performance in our latest version 22.2. We made significant optimizations in our VisualizeJS solution. So right now, I think that it works. It got the similar performance, but of course you need the numbers, and I already mentioned today that we are preparing right now performance tests, and we'll publish the results in near future in our documentation page. The next question, it's actually the similar question was already mentioned. Do you have any plans for CAD drawings like DWG? No, we don't have in our nearest plans to support some modification functionality for DWG files or other. But everything is changed, and you can push your requests, your requirement to our SIG group, and maybe it will be possible in the near future to support some this functionality. Okay, there was a question about the scaling of our solution. How many users in typical Azure deployment? We will provide the first numbers, amount of requests which can be proceed in our OpenCloud server in near future. We already prepare these performance tests and will publish the results in near future in documentation page. But there is another side, another part where performance is very significant, is when you need to convert your file to geometry representation, or for example, you need to extract properties data from the CAD or BIM files. This is really heavy process, and with our job runners, it's possible to scale this solution and to provide really good speed for your users. It's actually possible to provide the next workflow. So, for example, usually your service got, I don't know, maybe 100 or I don't know, maybe 1,000 users in a day. But in some specific days, you got a really significant amount of new users or new customers, for example, 10,000. It's possible to provide auto-scaling mechanism with our job runners. So in such days, when your system is understand that there is a huge amount of active users right now, so the system will raise new virtual instances with job runners. So the whole solution will be ready to process a huge amount of new drawings. So it's possible to implement such workflow with our OpenCloud solution right now. Okay, I think I answered on your question.
While you're picking up the next one, I'll answer this question. If we customize this, if our customers want to customize it further, would they need to become commercial members, or will there be something cheaper? As you know, all our membership levels, they fall into the distribution models. And if you plan to use this OpenCloud based solution internally, it is okay to have non-commercial membership and or commercial membership, because non-commercial membership may be used for 2 years only. If you plan to distribute commercially some OpenCloud based solutions or any other ODA based solution, you should be at least sustaining member. So briefly, the situation is the following. So for internal usage, any membership is okay, but for commercial distribution, it's necessary to have sustaining at least.
Okay, the next question. Do you have any support for issue tracking? Right now, no. We don't have support in our OpenCloud server this functionality, but I think that we will provide, maybe not in near future, but in this year, I hope so. Okay, the next question. What is the graphics engine used? We are using our own graphic engine. It's Visualize. with our rendering implementation, and we cross compile it to WebAssembly file format. The next question, is there any special reason to use Azure? Actually not. You are able to use any other cloud provider or even your own server. But for users who don't know which cloud provider is better to use, for such users we provide the documentation and help to deploy our solution to Azure. So only this is the main reason to use Azure. Okay, the next question is how to deploy locally. Okay, locally you can use the Docker. We provide short instruction how to install it on your computer. But I know, as I know, we got some problems to provide the Docker images for some users. It's an issue from our GitLab infrastructure. We are working right now on this problem. I know it. So if you got some problems with Docker installation, you can use our instruction. It's a little bit, it contains much more steps, but it really easy to, it's not easy, but it's possible to install locally without Docker and use and check our solution locally. And in near future, we want to provide console application. It's a small application which will install, which actually will perform all these steps for you. So you only need to run one command, and that's it. We are, I think that, I hope that we will provide this tool in near future. So it will perform all operations like install all dependencies for job runner, install and configure OpenCloud server, install and configure of our web viewer. So it will be much easily for you to deploy locally. But right now, I can say that only two steps. The first one is to use the Docker and Docker images from our Docker registry. Documentation you can find in our documentation page. But if for some reason it doesn't fit your requirements, you can check installation instruction. So it's like download archives of our OpenCloud server and install it locally. Then you need to download job runner and install it locally. Okay. Next question, is it possible to access IFC property set through the VisualizeJS? Yes, you can check it during extraction of, it's actually the same workflow as Autodesk Forge provide. So you need to upload your drawing, IFC drawing on the server, run job to extract properties data from this IFC file, and you can request these IFC properties through our REST API. The next question, is there a special dedicated support browser? It's not clear. You mean the list of browsers which worked perfectly with our solution. Maybe this is your question. Then I can say that all browsers which support WebAssembly can run our solution. So the main requirement for the browser should support WebAssembly format. As I know, there is no other some specific requirement to the browser. The next question: can open and edit or create custom entities? You are able to create new entities through VisualizeJS API, but these entities won't be saved to your original file, for example, DWG file. So if you need only to display some specific objects, specific geometry on top of the drawing, so yes, the answer is yes, it's possible. But if you want to modify some objects from the scene and save them back to original file, the answer is no. So such workflow is not possible right now. And actually, there are a lot of questions about editing of DWG file format. I can say that we spent some time to investigate and provide the DWG functionality. It's like a functionality for editing DWG in the browser, so without any backend. So actually it's possible. The performance is quite good for small drawings and for middle-sized drawings. So if you got the strong requirement for such functionality, please ask this from our Alex. Can you provide the link to our SIG page for customers who want to?
It is on the bottom of OpenCloud page.
Okay, thank you.
So of OpenCloud product page.
On the bottom of OpenCloud product page, please type your requirements, and I think that if we really got such requirements, such need from you, we will decide that we need to provide such solution and we'll start working on it. So how is the responsiveness when manipulating the screen? We are trying to provide the performance level on the 15 frame per second. So this is our limit when we start to remove some objects from the draw call list. So for the drawings of any size, we will provide at least 15 frames per second. So this is performance which we can provide.
Okay, probably it's necessary to think this information through. We will be glad to answer other questions. Please send us. Do not hesitate to address me or Ilya or whatever contact information you have to address your question regarding the OpenCloud SDK. We will send you all the links with today's video after we process it a little bit. So we'll have the record of this webinar. It will be published on our YouTube channel, but the links will be sent to everybody who participated. We are very grateful to you for joining us today. Hope that you'll be able to make some use and to find new opportunities. Thank you very much for joining, and we'll be glad to see you on our next webinar on April 22. Thank you, everybody.
Thank you. Thank you all for your questions.
Goodbye.
Goodbye.